All right, so today we're going to be talking about solving linear equations that have multiple steps. We've talked about solving equations that have just one step, and we had something like x plus 4 equals 3, and we had to subtract 4 from both sides, okay? And then we solved that one, so x equals -1. We did some like that. We did some with multiplying, like 2x equals -10, and we'd have to divide both sides by 2. So x equals -5. So we did some like that as well. Today we're going to be talking about ones where you have to do more than just one step. So it's going to involve some addition and some multiplication or division, depending on how the problem is set up. So the first thing we need to do is I want us to think about these things, and we're going to have a step-by-step later on in the section, but I just want to think about these. I want us to put our variables on one side of the equal sign. So I'm just going to put on one side of the equals, and then we're going to put our constants on the other side, because I really want variables on one side and I want constants on the other. So that's the first thing we're going to do. So if I'm looking at -3x plus 4 equals 19, over with the side that has the x on it, I have a plus 4. I want to move the constants first. I'm not worried about that -3 that's in front of the x first. I'm worried about the positive 4. So I'm going to do the opposite. So I'm going to subtract 4 from both sides. So then when I do that, I bring down my -3x, haven't done anything with him. I have an equal to, because those 4's would cancel. 19 minus 4 would be 15. Now it looks kind of like the ones we did at the very end of the last section where we had to divide in order to solve it. So I'm going to divide by -3 on both sides. So I get x equals -5, and that would be my solution. So the key was to move your variables to one side. In this case, I just had the one variable. It stayed on the left side. I needed to move that constant that was over there to the other side of the equal sign. So the plus 4 needed to move over, and then I could divide to solve the rest of it. Also, you can go back and check these. If I want to put my -5 in for x up there and then work it out using order of operations, I could do that as well. Okay, let's look at the next one down. We've got 6 equals 1/4 y minus 2. This time the variable is sitting on the right side. I have a 1/4 in front of it. I'm going to take care of that later, but I have a -2 out to the side. So the first thing I want to do is move that constant to the other side. So in this case, the constants are moving to the left side, and that's fine. So 8 equals 1/4 y. Now, we talked about how to cancel out a fraction. If I want to cancel out a fraction, I multiply by its reciprocal. In this case, 1/4, the reciprocal would be 4/1. So I'm just going to multiply by 4 on both sides. So the 1/4 will cancel. 8 times 4 is 32 equals y. So that would be the answer for that one. Okay, so we're moving variables if we need to, we're moving constants if we need to, and then a lot of times what you end up doing is dividing at the end. Let's look down at the bottom. I've got an equation. It's got -7w minus 5 equals -19. In this case, same thing. We've got the w over there on the left-hand side, so I'm going to work with this -5 first. We're going to add 5 to both sides, because that's the opposite. We're going to watch our signs, because we have a -7w equals -19 plus 5. We've got to think about negative and a positive. So subtract them. 19 minus 5 would be 14. And it's going to be negative because the 19 was bigger, so it stays negative. Now I've got an equation that has a -7 times w. So the opposite of doing that would be to divide. Now, when you have a negative with your variable and you want to divide and cancel it out, you need to also divide by that negative, because we want to come out with a positive W, because those would cancel. Then negative 14 divided by negative 7 would be positive 2. So far, so good. Okay, let's move on. Now, here we have some, and you'll notice this one has variables on both sides of the equal sign. So what I'm going to do is I'm going to move the variables first. And we're going to move those variables by adding or subtracting. So I have a 9x on the left side, a 2x on the right side. I want to bring those together, so I'm going to move the 2x, so I'm going to subtract 2x from both sides. So 9 minus 2x would be 7x. I didn't do anything with the plus 2, equals, I don't have x's over here on the right side anymore because I moved the 2x, so I just have the 23. Now it looks like the ones we did on the previous page. I've got 7x plus 2, so now I need to move my constant numbers. I'll move those to the other side, so I get 7x equals 23 minus 2 would be 21. Now divide both sides by 7. 21 divided by 7 is 3. So x equals 3. So on this one, we moved our variables first. Then we move our constants. To the other side. The pen is wanting to be a little slow today. Okay, that's the key. Moving the constants to the other side. Now this one below it is the same exact problem, so there's no need to do that one again. Let's go to the bottom of the page. Here we've got a 6b minus 20 and equals a 14 plus a 5b. Now it is totally up to you which side you want to put your b's on, your variables in this one. If you want to put them all on the left side, that's just my habit. I always put them on the left side, but you certainly don't have to follow that all the time. I'm going to do that though. I'm going to move my 5b over here with my 6b. So I get all my b's on the left side. So 6b minus 5b just gives me a b. 1b, you can put the 1 if you want to, minus the 20 equals 14. So now I've got minus 20. He needs to move, so we're going to add him because he's a minus. Opposite would be a positive. So then those cancel, so b equals 34 when I add those together. This time I didn't have to divide because there was a 1 in front of that b, so that kind of saved me a little bit of time. Now remember, if you need to stop this video, work some problems, and then come back to the video, be sure and do that. That just helps you out. Alright, so here I told you we were going to get to a place where we had procedures. Here are our steps. Right there. We are simplifying both sides of the equation. That means we might need to clear parentheses or clear fractions. We're going to work with that in just a little while. So we have to do that. Simplify both sides of the equation. So collect all variable terms on one side of the equation and then the constants on the other. Now, when we're clearing, back up to step 1, when we're clearing our parentheses or clearing fractions, then I want you to collect any like terms. Before you go to step 2, you need to collect any like terms. It's just going to make your problem a little bit easier to deal with. And then variables will go on one side, constants on the other side. Use the multiplication or division property to get a 1 in front of your variable. Okay, those are our steps. So let's look at this first one. It looks really difficult because it's long, but we're going to take it in chunks. Let's look over on the left side. I see right away I have an 8 minus 3. Well, I know I can simplify that to 5. So I have a 5 plus y. That simplified that side a lot. I see a parentheses on the other side. So if you remember, that's called the distributive property. hippity-hoppity distributive property, we're going to clear that parentheses. 3 times y is 3y. 3 times 4 is a plus 12. And then I have a plus 15 out to the side. Now, I cleared the parentheses. I still see a little bit more work I could do over on the right side because I have a 12 and a 15. Let's put those together. So 5 plus y equals 3y. And I'm going to say 12 plus 15, that's going to give me 27. Now, looks like the ones we were doing on the previous page. I need to put my y's on one side, my constants on the other. So I just like putting my variables on the left. You don't have to always put them on the left if you don't want to. I'm going to move the 3y. So I'm going to have 5, and now I've got 1y minus 3y, which gives me negative 2y equals, the 3y's went away on the right side, so I'm just left with 27. So variables are on the left side. I'm good. The 5 is what needs to move now. So I'm going to subtract 5 from both sides. So I'm going to have them come up here. I've got a negative 2y. Now, don't forget to bring that negative with that 2y because it's right smack dab in front of it. Then I've got 27 minus 5. That would be 22. Now I divide both sides by negative 2. So y equals 22 divided by negative 2 would be negative 11. And there would be my answer. So it's going to take you a few steps to do some of these. It just depends on if they've got a lot going on. If they've got parentheses going on, things like that, there could be a lot going on. Alright, let's do one with decimals. You may watch something, you may see in the book where it wants you to clear decimals. Most of y'all are using calculators to work on these, so I don't find that it's really necessary to clear decimals because we're just going to go in here and we're going to use our calculator to add and subtract these decimals. So I'm not really concerned about clearing decimals. So if you see something like that, don't worry about it. Just use your calculator. So I'm going to move my variables. So I'm taking 6.8 C minus 1.2 C. So 6.8 minus 1.2, that's going to give me 5.6. So 5.6 C minus 2.7 equals 58.9. Now I've got my C's over here on the left, right there. So I'm going to add the 2.7 to get it to the other side. So now I've got 5.6 C equals, I need to take 58.9 and I need to add 2.7 to it. So that gives me 61.6. And now we're going to divide by that 5.6. So if I take 61.6 divided by 5.6, I get 11. Comes out nice. So it comes out to a nice 11. So you don't have to worry about clearing decimals. I don't really concentrate on that because you're using a calculator for those decimals, and that's just fine with me. Alright, so let's try this one. We've got parentheses. Now I've got things going on. I see a 1 minus a 4. I'm going to put those together on the left side. So negative 3 minus 2x equals, I have an x. Now I need to distribute the negative 5. That's a negative 5 because I got that negative right there in front of it. So negative 5 times x would be minus 5x. Negative 5 times a negative 7 would be plus 35. And then I have a plus 4 out to the side. Now that right side looks like it's got a lot to put together. So let's just copy down the left side. Negative 3 minus 2x. Can't do anything with that. Okay, on the right side I have an x minus a 5x. So that's negative 4x. 35 plus 4 is a positive 39. Now that cleaned it up a little bit. Alright, so now I'm going to move my x's to one side. So I'm going to add 4x to both sides. So I have negative 3 plus 2x equals 39. Move your numbers. Add 3, since that's a negative 3, do the opposite. So 2x equals 39 plus 3 would be 42. Divide by 2. So x equals 42 divided by 2 would be 21. That would be my final answer. I'm going to leave the one at the bottom for you to try, and then you can email me if you want to know the answer to it. Let's look at the next page. The next page is just talking about conditional and no solution. Let's go back to that one. Let's work that. Let's go back to the one that was at the bottom of that page. I think you're going to see more like this than anyone. So let's go ahead and do this one. So I'm going to take 3 and I'm going to, now do not make the mistake of taking 3 minus 5 and putting negative 2 there. You cannot do the subtraction until you clear the parentheses. So negative 5 times 9 would be minus 45. Negative 5 times a negative w would be plus 5w equals, on the other side, I'm going to distribute the 2. Get 2w plus 8 plus 1. Alright, let's see what we can put together. 3 minus 45 gives me minus 42 plus 5w equals 2w, can't do anything with that. 8 and 1 gives me a positive 9. Let's put our w's together. So I'm going to subtract 2w from both sides. So negative 42 plus 3w equals 9. Let's add that 42. Move him to the other side. He's negative, so I got to add him. Cancel him out. So 3w equals 9 plus 42 would give me 51. And then we're going to take 51 and we're going to divide it by 3, and that's going to give me w equals 17. There we go. Okay, now when I looked at this next page is talking about decimals. I'm not worried about these decimals. We're going to use a calculator for the decimals, so I'm not going to worry about those. Let's talk about what happens if variables should cancel out, which that can happen sometimes. If you'll look at this one, if I take x plus 3 and I set it equal to 8, we would solve that by taking minus 3 on both sides and getting x equals 5. That means that that's a conditional equation. We got an answer for that one, okay? So you got it, it's a true statement because if we use 5, 5 works. But look at the one below that one. We've been putting our variables on one side, so if I follow that pattern, I would subtract x from both sides. Well, what happens is, if x minus x, that cancels out on the left side, and I'm left with a 1. X minus x would cancel out on the right side, and I'm left with a 2. Well, 1 does not equal 2. That's a false statement. So, if every so often this can happen, this doesn't happen often. Every so often, if you have your variables cancel out and you end up with a false statement, that means we have no solution. I don't ask you if this is a contradiction, I just ask you what the solution is. So you put no solution. Now the one below it, if I follow the same pattern and I subtract my x's from both sides, and I see that these x's are going to cancel, but I end up with a 5 on the left side and a 5 on the right side. That is a true statement. This is true. So that means that my answer for this equation is all real numbers. Now what that means is that I could put in any number and substitute it in for x and that would work. That's what all real numbers are. The one above it, when it was false with no solution, that just means that there's no number I can put in there and make it work. Alright, so on these back ones, those are just identifying if they are conditional or not. Okay? Just keep in mind if you work a problem and you have all your variables canceled, look to see if it's true or false what you have left. Alright, that is solving equations with multiple steps. Hopefully we're going to be able to get through them and be very successful.